Okay, today we begin the sum and difference identities. There are going to be 6 new trig identities that we're going to learn today. With these identities, we want to be able to find exact values, show statements are true, and simplify statements. Okay, so these are the 6 identities that we will be using today. Cosine, sine, and tangent kind of all have their own little thing. The big thing to remember with cosine compared to sine, in that matter, is cosine you're going to have opposite signs versus sine, which are going to be the same. And then also, with cosine you have cosine, cosine versus sine, which has sine and cosine. Sine and cosine versus cosine, cosine. Okay, so let's get started so you guys don't have to listen to me talk for half an hour. Okay, first example. The thing you want to do is make it what you know it could be or what you already know, if that makes sense. Now I'm looking at sine and I tell myself, okay, sine of 75 degrees, or sine 75 degrees can also be written as sine of 45 degrees plus 30 degrees. Okay, well, we know that from our identities on that first page, the sine identity, we have a plus here. So we're going to rewrite this as sine, I'm going to just write this right, like cosine, sine, cosine. Okay, now the question is, I need A and a B. Well, here's my A, here's my B. So I'm going to put 45 degrees in there, 30 degrees in here. And so I have a plus, because the sign stays the same, sine of 30 degrees cosine of 45 degrees. Okay, right off the top of your head, you should be thinking unit circle. Sine of 45 degrees, what is the y coordinate? Well, we're going to say, or it is, I should say, the square root of 2 over 2, and then cosine of 30 degrees is the square root of 3 over 2. Now for the other side of the plus sign. Sine of 30 degrees now is 1/2. Cosine of 45 degrees is square root of 2 over 2. And now it's simple, you're just multiplying now. So we have the square root of 6 over 2 plus the square root of 2 over 2. Now I would accept that answer, or you can also write the square root of 6 plus the square root of 2. Remember, if we don't have like radicals, you cannot add, or like numbers underneath your radical, we cannot add those. So there we go. Now we're going to work on cosine. We have 7 pi over 12. Once again, make it what you know, or things you already know. Well, we know cosine 7 pi over 12 can also be written as cosine 3 pi over 12 and plus 4 pi over 12. Okay? So we have 2 angles now that will add up to be our 1 angle. The question is, can we simplify these and make them look like something we already know? Yes. So we have, which is equal to cosine pi over 4 plus pi over 3. This is looking kind of familiar now. Okay, so now cosine has cosine, cosine. And then opposite, remember this, opposite the sine. So I'm going to have minus, let me get you a little bit more room here, minus sine. Okay, now we need to have an A and a B. Well, I have an A right here. Change colors for you. I have an A right here and a B right here. So now we just put those numbers into the spots that we know. So we have pi over 4, pi over 3, pi over 4 again, and pi over 3. Okay, now you should be asking yourself, okay, unit circle once again, what is my cosine at pi over 4? Well, it's the square root of 2 over 2. And then cosine at pi over 3. Well, that's over 60 degrees. That's at 60 degrees. So I know that one's going to be 1/2. And then minus sine of pi over 4 to square root of 2 over 2 again. And then we have sine at 60 degrees, which is square root of 3 over 2. All right, now it's just a matter of solving. So we have the square root of 2 times 1 is the square root of 2. 2 times 2 is 4. Minus the square root of 2 times the square root of 3 is the square root of 6 over 4. Once again, we can't add two numbers underneath radicals unless the numbers are the same, or subtract. We have the square root of 2 minus the square root of 6. All over 4. Awesome. Okay. Now we're going to change gears a little bit. And now we're going to show that cosine, or we're going to prove, I should say, or show, whichever one you want to do. So it says show that cosine x plus 2 pi is equal to cosine x. Well, we're going to use the cosine identity. So we have cosine, and then your sine is a plus, so it's going to be minus sine. So now we're going to just plug in our A and our B. So our A is x, our B is 2 pi, x and 2 pi. Okay, now think about the unit circle once again. Cosine of 2 pi. Well, that's just 1. So we have cosine of x times 1. And now sine of x. Sine 2 pi is just 0. So that's going to be 0. Well, we know that cosine of x times 1 is just cosine of x, and then sine of x times 0 is 0. So I'm just writing minus 0, which is equal to cosine. That's a nice cosine of x, huh? I like writing e's after my cosine for some reason. Cosine of x, which is equal to cosine of x. Okay, awesome. Let's keep moving. That was nice and quick. Don't we like those ones that go by fast, so we don't have to listen to me talk more than what I need to. Okay, now we have tangent. Kind of a different animal here. Tangent, we kind of have to look back at what we need for tangent. So let's quick go back, and we see that tangent x, we have an x minus pi over 4, so we're going to be using this one down here. So let's go back. So okay, now we have a tangent A, it was tangent A, so I'm going to mark my A and my B. Tangent A, which is x, minus tangent B, which is pi over 4, all over 1 plus tangent A times tangent B. Okay, you should be looking at this thinking, well, tangent pi over 4, that's just 1. Which you're right if you're thinking that. So tangent x minus 1, and then 1 plus, if tangent pi over 4 is 1, it's just plus tangent x. Well, you're saying, oh, it's not quite the same. Remember, addition is commutative, so we can put it in any order. So I'm going to change that to just tan x minus 1 all over tan x plus 1. Okay, now we're cruising right along now. Let's go to the next one. Okay, we need to write cosine 3x times cosine 2x minus sine 3x times sine 2x as a single cosine. Well, here we're already given the identity. We just have to identify the A and the B. Here's the A and the B. So I know just because we have a cosine, and then we also have to look at this negative sign. So we know it's going to be cosine because we start out with 2 cosines. So we're going to say cosine. And then, like I said before, we have a negative, so I'm going to put a plus. Well, then I can put my A in, which is 3x, and my B in, which is 2x, which is equal to cosine 5x. And we're in cosine. That's neat looking rectangle there. Okay, now we're going to work with the next one. Here we have a sine cosine. Well, right away I should tell myself, okay, I need to use sine because it's not a sine sine or a cosine cosine. It's sine cosine. So sine, and now I need an A and a B just to make sure I have the same A and same B. Otherwise, it's not going to work out, right? So sine A is 5x, and the addition or subtraction sign in the middle stays the same, so 5x plus 2x, which is equal to sine 7x. Okay. Now we got to make things a little bit more difficult. This stuff's getting a little bit too easy here. So let's go with turn the page. We have sine A equal to 3/5 in quadrant 1. Cosine B equal to negative 5/13 in quadrant 2. Okay, right away, I'm given distances and quadrants. So I'm going to graph this right away. So I'm going to have 2 different graphs. The sine A I know is in quadrant 1. So I'm just going to draw right away in quadrant 1. Well, sine is opposite over hypotenuse. So 3, 5. Oh, this is a famous triangle right here. Famous, very famous triangle. The 3, 4, 5. It's a fun one. Okay, and then the next one we know is in quadrant 3. So I'm going to just draw this down here. And now we have a hypotenuse of 13. And our adjacent triangle, or adjacent side, is going to be negative 5. And this one, this side right here, which is our opposite side, if we do the math, 13 squared is 169, well 5 squared is 25. If I subtract 25 from 169, we get 144, which the square root of that is 12. It's going to be negative 12 because we're in quadrant 3. Okay, so now we know what sine of B is. Which is equal to negative 12/13. And cosine of A, which is 4/5. And you're asking me, why did you just find that? Well, think about the context of the question. We're working with the identity, so I know we're going to have to find those two. And we look down here and, oh, we have sine A plus B. Okay, so I have sine, so I'm going to put sine cosine. Keep my addition. And then sine cosine. Well, now I need my A, which is going to be like that. Cosine B, sine A. Oh, don't do that. You want to make sure we keep our proper things in order. So we have already used sine A, so we want sine B. And we've already used cosine B, so we're going to use cosine A. Well, now we just can look at what we found or what we have. Sine A is 3/5. Cosine B is negative 5/13. And then we're going to add sine B, which is negative 12/13 times cosine A, which is 4/5. One good way to know that you're kind of headed in the right way or the right ball game, you're playing the right game, is look at your numerators in each one of your fractions, and you should be able to use all the legs of the triangles you have. And then the same thing with your hypotenuses, they should be one on each side. So, okay, now we have a negative 15 over 65 minus, because we're going to have a negative 12 times 4, you can just multiply straight across when we're multiplying fractions, 48 over 65, which is equal to negative 63 over 65. Okay? Now let's go over to the next one. We have cosine A minus B. Well, we got to go back and think, okay, cosine is cosine. Cosine, the opposite sign, so we're going to have a plus. Sine, sine. Well, we can just put in our A. Okay. Do we have a sine A and cosine? Yeah, we do. We've already found all that. So cosine A is 4/5. Cosine B is negative 5/13. Plus sine A is 3/5. Sine B is negative 12/13. Okay, now just multiply straight across the top of our fraction. So we have negative 20 over 65 minus again because that negative 12, and so we have negative 36 over 65, which is equal to negative 56 over 65. Okay, so that's pretty good there. And now for the next one. We're going to actually assign this one. I want you guys to do this and hand it in tomorrow, or I should say try it, and we'll do it on the board. You have a good evening, and I'll catch you on the flip side.